In this lesson, we are going to learn about graphing exponential functions by transformations. Now, before you do anything, you really should make sure that you've completed the investigation part by yourself. It does say to complete on your own. And if you have not completed this yet, you need to pause the video now and do it on your own before we get started. So I will take up just the answers quickly so you can check to see if your answers were correct. But if you have not done this investigation yet, you need to pause the video now and do it. So for the first three graphs, the y-intercept of the first one was 1, the horizontal asymptote was 0, and it was increasing. There was no comparison because it's just the original graph. Graph number 2, the y-intercept is 4, the horizontal asymptote is 3, it's increasing, and if you compare it to the original function, it is higher, it's been moved up 3 units. The next one has a y-intercept of 6, it has a horizontal asymptote of 5, it is increasing as well, and if I compare it to the original one, I wrote here that it's moved up 6, but it's actually only moved up 5 units. If I take a look at the last two, this one has a y-intercept of y equals -2, a horizontal asymptote at -3, it is increasing, and this graph has moved down compared to the other one, so I said it's moved down 3. And then this one here, we have y equals -4 as our intercept, -5 as our asymptote. It is increasing, and it has moved down 5 units. If we take a look at the next page, this one you had to do a little bit more work for because you couldn't really see the y-intercept on most of them. So this one here had a y-intercept of 1, a horizontal asymptote of 0, and it was increasing. That's still just 2 to the x. It was the same from the other page. Now here I couldn't make out what the y-intercept was, so I had to calculate it. We find y-intercept by subbing in 0. That was in an earlier lesson. So 2 to the power of 3 was 8. It was a horizontal asymptote at 0, increasing, and when I take a look at the 3 key points, they've clearly moved to the left 3 units. To find the y-intercept of the next one, I subbed in 0 for x, so 2 to the power of 5 is 32. The horizontal asymptote is 0. This is increasing, and if I take a look at the points, they have all moved left 5. And then if we take a look at the last part, the y-intercept here, I had 2 to the power, I put 0 in for x, 2 to the power of -3. Remember, a negative exponent makes a fraction, so I flipped that over to become 1/2 to the power of 3, which is 1/8. The horizontal asymptote is 0. This is still increasing, and I've noticed all the points have moved to the right 3 units. And the last one here, we have 2 to the 0 minus 5. 2 to the -5, a negative exponent makes a fraction, so I flip it over to make it 1/2 to the power of 5, which is 1/32. The horizontal asymptote is 0. It's still increasing like all the rest. And this one, all of the points have moved to the right 5 units. So what we're going to take a look at is horizontal and vertical translations today. And we're going to talk about how to graph them. I'm just going to zoom in a little bit here. We're going to start by just identifying what h and k do in an exponential formula, and then we're going to make a graph. So I know this is exponential because I see that I have the x in the exponent. That's usually how I can identify an exponential function. The x is in the exponent. And I have 2 letters that we've seen before. These are the same letters that we used when we did parabolas back in our quadratics unit. Now, hopefully from the investigation, you figured out what k did. It seemed to move the graph up and down, which are called vertical translations. To move it up, it needed to be a positive number, and to move it down, it was a negative number. Now, the h inside the bracket, instead of moving up and down, moved it left and right. And we discovered when we looked at our investigation that a positive moved it to the left, and a negative moved it to the right. Now, when I do look at my examples, I noticed for k there was one more thing that it did. It moved it up and down, it moved the curve, it also moved the asymptote. And I noticed that if I look here and it says +3, my asymptote was at +3. And here when I had plus 5, the asymptote was at plus 5. And here when I had minus 3, the asymptote was at minus 3. So aside from just moving it up and down, k is also the asymptote. So what we're going to do are some graphs. We're going to graph two exponential functions, and we're going to go through a process that's a little bit new to us. We haven't really done it this way before, but hopefully with practice you're going to get really good at it, because this is a method we are going to use throughout the rest of the semester for graphing. So it says for each of the following functions graph each of the following functions on the grid below, and I have y equals 2 to the power of x and y equals 2 to the power of x minus 4 plus 1. And we want to do this using transformations. That's the whole point. So we're going to use the left, the right, the up and down to figure it out. So for the first one, for what we like to call the base function here, a base function is always going to be something to the x. So 2 to the x, 3 to the x, 1/2 to the x. Our base function here, 2 to the x, we're going to make a table of values. We've done this before as well. So I'm going to substitute all of these numbers in for x in my equation. And personally, I like to start at the bottom. I find that a little easier. So you can use a calculator or you can just figure it out in your brain. It's up to you. So I'm going to start with 2 to the power of 4. 2 to the power of 4 is 16. And then 2 to the power of 3, which is 8. 2 to the power of 2 is 4. 2 to the power of 1 is 2. 2 to the power of 0, anything to the power of 0 is 1. 2 to the power of negative 1. Now a negative exponent makes a fraction. It has a flipping over action. So if 2 to the power of 1 is 2, then 2 to the power of negative 1 gets flipped over and becomes 1 over 2. And I would rather you write the fraction here than the decimal. 2 to the power of negative 2 is going to be the same as 2 to the power of positive 2, except the negative flips it over to make it a 1 over 4. The negative 3 is the same as positive 3, but flipped, so 1 over 8. And negative 4 is the same as positive 4, but once again that fraction, so it's going to be 1 over 16. Now this is the new part. This is something we haven't done before. I want to graph y equals 2 to the power of x minus 4 plus 1. So the first thing I'm going to do is I'm going to take a look at what the transformations are. So the best thing to do is to start by trying to figure out what the base is. So if I take a look here, the base is the 2, right? That's why we started with 2 to the x. My base is 2. So I have a plus 1 at the end that does something to that graph. And then I also have this minus 4 that's going to do something else to my graph. So the plus 1 is that k value, and it should, as we said before, move the graph up and down. So since it's a positive 1, this is going to move the graph up 1. And then the minus 4 is going to move the graph to the right 4. Now this is where I stop and I take a second and I ask myself what up 1 and right 4, what part of the graph that's going to change. So if it's moving up 1, does that change the x or the y? It changes the y value by moving it up 1. So we're going to add 1 to our y value. Now when I move to the right 4, that changes the side-to-side value, that changes the x. And it always does the opposite of what we see. So if I see a minus 4 in here, we're actually going to take x and we're going to add 4. So what I'm going to do is take my base function of 2 to the x, and I'm going to add 4 to all the x values, and then add 1 to all the y values. So to help me do that, I'm going to cover up the y values so that I don't make a mistake here. And I'm going to take each of my x's and I'm going to add 4. So negative 4 plus 4 is 0. Negative 3 plus 4 is 1. Negative 2 plus 4 is 2. Negative 1 plus 4 is 3. 0 plus 4 is 4. 1 plus 4 is 5. 2 plus 4 is 6, 3 plus 4 is 7, and 4 plus 4 is 8. And then I'm going to do the same thing with the y's. I'm going to cover that up so that I don't accidentally use those numbers. I'm going to move this over. For these ones, I'm going to start with the ones that are a little easier. Usually for this side, I would probably use a calculator. So I'm going to start at the bottom because those look easier. So 16 plus 1. 16 plus 1 is 17. 8 plus 1 is 9. 4 plus 1 is 5. 2 plus 1 is 3. 1 plus 1 is 2. Now this is where it gets tricky. If you're good with fractions or you're good with calculating that in your head, that's a good thing. Otherwise, I'm going to use my calculator here. So I'm going to take the next number, which was, I hope I didn't cover everything up. Okay, let's try this. There we go. So 1/2, I'm just going to do 1 divided by 2 plus 1, which gives me 1.5. And then 1 divided by 4 plus 1 is 1.25. 1 divided by 8 plus 1 is 1.125. And then 1 divided by 16 plus 1 is 1.0625. So all I'm going to do is I'm going to graph these two. I'm going to start with my base function of 2 to the power of x, since it did ask me to graph both of them. So I'm going to try, we'll zoom out here, to plot those points on my grid. So sometimes it does help if you mark on some form of a scale, either by 2s or 5s or something. Makes it a little easier when you're trying to count out numbers like 16. Okay, so I marked on a little bit of a scale. I know it's really small. We'll try zooming in a little bit more. I'm going to plot my first point. I'm going to start with the ones that are the whole numbers on the bottom and then work my way up to the fractions. I'm going to start with 4 and 16. So 4 and 16. And then -3 and 1/8. Oh, nope, sorry. 3 and 8. So 3 and 8. Helps if I check them off as I go. 2 and 4. 1 and 2. 0 and 1. -1 and 1/2. So that's going to be halfway through that square. And then 1/4 is going to be about half that distance. And then 1/8. And then 1/16. It's really hard to start marking those on. So one side reminds me very much of a parabola. So we go all the way up with an arrow on the end. And then the other side gets closer and closer and closer to 0 because we keep getting a smaller and a smaller and a smaller fraction. So we draw the line leveling off at the asymptote all the way to the end with an arrow. All right, so let's do the next one. So I'm going to plot the points. I have 8 and 17. 7 and 9, 6 and 5, 5 and 3, 4 and 2, 3 and 1.5, so that's 1 and then halfway through a square. 1.25 is going to be a little bit closer to 1, and then 1.125 is a little bit closer to 1, and a little bit closer to 1. I draw the side that looks like the parabola going up, 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 up. And on the other side, the number's getting closer and closer and closer to